Hello. Can you hear me okay? Yep. Great. My name's Guy Bowerman. This is Neil Gatt. We are program managers in the Azure Compute team, and we're part of the team that built virtual machine scale sets. That's the topic of this session, Autoscale your applications with VM scale sets. Now, VM scale sets have been GA for maybe about 6 months now. So this is a nice opportunity for us to share some of what we've learned in the last 6 months about how our customers and partners are using scale sets, and also talk a little bit about some of the things that we're working on as well. So just going to start with why we built the service in the first place, and then talk a little bit about how you can actually get started with some of the basic operations like deploying scale sets, deploying applications, and then talk a little bit about some of the more advanced operations, things like how do you upgrade your scale set. And then we'll go into scale and then go pretty deep into Autoscale as well. Just a quick check. How many people here have deployed a VM scale set? Okay, so I'm kind of thinking I'm seeing a little bit under half, maybe a third, so that's good to know. So we'll start with, why did we build this service? What was the need we were trying to fill? Maybe if I just take an abstracted look at what the compute requirements of a modern cloud app are. You've got some virtual machines, and they need to do work. This is going to be in the context of some kind of networking environment where you have incoming connections. Maybe there's load balancing. Maybe there's direct connections. Now, the key value prop of the cloud is that you can scale these compute nodes, and you can increase the size of your compute layer to do extra work. You can decrease it when you have less work. That's really one of the key value props, and that's one of the it needs to be easy. It needs to be easy. It needs to be cost efficient. Of course, there's other things even in our abstract app. There's a data layer of some sort. Maybe there's a database endpoint. Maybe there's attached drives. Maybe there's shared drives. You also may have a fixed number of virtual machines, perhaps control nodes, specialized virtual machines. That can actually be important, because if you have an undifferentiated layer for doing compute, then it becomes easier to scale out and scale in. So we're going to really look at this layer, explain why we felt we needed a new service, and then how scale sets makes things easy for this doing compute in the cloud. So what this compute layer really needs, in particular scale, it needs to be able to scale out quickly. It needs to be able to scale out automatically where necessary, like in response to a spike in usage or resource demands. And it needs to be transparent. In other words, you shouldn't have to go and mess with infrastructure just because you want to increase the number of VMs you have. You should just be able to say, I want more VMs. The infrastructure should take care of itself. And really, it's about manageability as well. How do I start 100 virtual machines? You may have a script that starts 100 virtual machines, but you have to think about it quite carefully, how you would start that. Will they all start in parallel? Those kind of problems are the kind of problems we were looking at with scale sets. Similarly, it needs to be highly available. If a rack in the data center catches fire, do you lose all your compute VMs, or are they spread out evenly across fault domains? Security, patching, upgrade. So everything has a life cycle. At some point, no matter how you manage your applications, at some point you're going to need to upgrade your VMs. You're going to need to apply patches. So that needs to be thought about as well. So these are the main requirements that we looked at when we built scale sets. So basically, VM scale sets, at the core, is scale. It's very easy to scale a VM scale set. You just change this value capacity. So that's then easy to build into things like Autoscale. Because it's just part of Azure infrastructure, it's very customizable. So there's a lot of features that you get with, like PaaS v1 worker roles. Anyone used PaaS v1? Okay, about a similar number to have deployed scale sets. There's a lot of kind of features there to manage VMs at scale. We wanted to have those features, but we wanted all the customization of the Azure Resource Manager provides. like being able to deploy Linux VMs, things like that, being able to choose your networking infrastructure. So availability, it needs to be easy to roll out updates, and scale sets are a way of, because they're easy to dynamically increase or decrease, you can really optimize costs. And again, that comes back to the key value prop of the cloud. And it's that integration with Autoscale. They are very easy to integrate. And I think what I'm showing there in the screen is around availability. If you create a scale set, these are like, they're kind of evenly distributed across fault domains in your data center. So if one server does catch fire, you've still got 80% of your scale set is still running and providing a service. So in the context of Azure Resource Manager, so scale sets are a resource built on top of Azure Resource Manager, just like virtual machines. So if I'm deploying a scale set, I could either create a resource group in advance or create a new resource group and a VNet and a subnet. And then there's the concept of a scale set resource, where I say, I want this many virtual machines. These are its properties, including network properties, storage properties, and then I may want to decide what runs when the VM gets deployed, so I may have VM extensions as well. And then effectively the same extension will run on every VM when I scale out or when I create a scale set. So behind the scenes, typically you create a template, or there's some kind of JSON body if you're just doing a put on the API. So you have a template that describes the virtual machine scale sets resource, and the most important property is capacity. That says how many instances of, how many VMs do I want this to create. And then it's very easy to change that number. You can just change that number and redeploy, and you can scale in and scale out. And I'll talk a little bit about how to do that. So that's the theoretical basics of VM scale sets. Now let's just look at some practical ways that you can get started and do basic operations with scale sets. How do you deploy a scale set? Well, directly in the portal. We've been working on the template that the portal uses behind the scenes. So when you go create a new scale set, you'll see various options. You can choose between Windows and Linux, and now you have Autoscale options as well. I'm not actually going to demo that because during this hour you will see as much of the portal as you probably want to. So we'll leave that till later. I think maybe I'll demo creating a scale set from the command line. So let's go to my machine. Here's a command line. This is actually the bash shell on the Windows 10 Anniversary Edition with Azure CLI installed. It's quite a nice way to, that I like to use the command line. I could use PowerShell if I wanted to. So I've got a couple of scripts here. If I look at what I call VMSS Quick, this script, it creates a resource group called gbignite1, and then it calls the Azure CLI command Azure VMSS Quick Create. So that's like a shorthand that's provided to you that creates all the resources that you need to have a VM scale set, including a load balancer and a public IP address and inbound NAT rules. And you can condense it into one little command. As you can see, I'm providing a user and a password. I could alternatively provide a certificate there. If I wasn't doing a demo, I probably would. And you've got this shorthand way of saying what platform image you want. So I've put like CoreOS stable latest. So I'm going to create a CoreOS VM scale set. So I can just go, I can just run that. And it will start trundling away, assuming I have a network connection. So first of all, it goes and creates the resource group. And then once that resource group is created, it goes and it's basically behind the scenes, it's following a template and it's going to start building all the resources required that the scale set depends on, and then it's going to build the scale set. So it's a very easy way to deploy a scale set. And I mentioned a couple of times behind the scenes it's running a portal, running a template. So if I go to GitHub and look at Azure Quick Start templates, we've provided several example templates that deploy virtual machine scale sets or applications based on virtual machine scale sets. These aren't all of them. There's a few more in other parts. It's a long list of templates. But there's some good examples here. If, for example, I click on VMSS bottle Autoscale. So what this does, it runs a script which goes and installs Bottle, which is like a Python web app. And it runs a little Bottle app where you can then kick off an engine to do work and watch it autoscale. And so it's got this portal which, it's got this template which pretty much anytime you deploy a scale set in the portal or using Quick Create, it's going to run some kind of template which defines all the resources that it needs. I know it's probably not very visible here, but I'm not going to go through the template itself. I could, if I wanted to, click on Deploy to Azure, and it would take me to the portal and ask me to fill in all the parameters that I have. But since I'm in a scripty mood at the moment, I'm going to deploy this template from a script as well. So let's bring up another bash shell. So I've got another script, and what this script does, is it visible, by the way, or am I just yep, it is more or less visible at the back. What this script does, it creates another resource group, and then it does a deployment, Azure group deployment create, which specifies the URI to that template, which creates the Bottle application. So that's really just in a way like you can do deploy any other Azure resource. So I can go and deploy that. So again, very easy to deploy a scale set. So for now, I'm going to switch back to the slides. We can always go check on that a bit later. So that's the command line. That's using a template. And of course, SDK or REST, really like any Azure resource. You can just create a scale set like that. But how useful is that? Really, you want to deploy an application, right? This is really just the underlying infrastructure. So how do you actually deploy an application on top of a VM scale set? You saw one method, which is that template was a little Bottle application. It actually used a VM extension to go and install what was required for that application on all the VMs in the scale set. But since this is really fundamental to why you would use a scale set, I'm going to pick out 6 patterns of application deployment and talk a little bit about how you would use them and why you would use them. And keep in mind, a lot of applications may use several of these application deployment methods. So let's start with perhaps the easiest one, which is if there's an application that's built on top of VM scale sets and somebody's created a marketplace entry for them, then it's very easy. It's an off-the-shelf marketplace solution, and you can go deploy it directly from the Azure Marketplace. What's nice about that is that somebody else designed the infrastructure. Somebody else said what should, again, there's a template in the background, but you don't have to care about it. Someone else designed it. So if what you need is in the Azure Marketplace, or if you're building a solution that you want other people to use and you put it in the marketplace, then it's very easy. You just go deploy that. So that's really application deployment method 1, the easy off-the-shelf solution. And we'll go the other direction now. I mentioned a little bit about VM extensions, and if you look in Quick Start templates, you'll see a lot of scale sets that use VM extensions. And this is really, if you want to control all of the infrastructure yourself, you can just run a custom script directly as you deploy a scale set, because a scale set has a property called an extension profile. So you can define your application and have it basically installed from an extension as part of your initial scale set deployment. But you could also just go to the portal and create a scale set, and then you could apply an extension on top of it. And what that will do is it'll update the scale set model, and then any new VMs will run this extension. And you can also call upgrade on any existing VMs to run this extension. And I'll be talking more about how you do this rolling out an update. It applies to extensions as well as certain scale set properties, such as the OS version as well. So we tend to find a lot of people use VM extensions because it's just the most direct way to install an application on a VM scale set. However, supposing you're creating infrastructure where the VMs don't have external network connectivity, or maybe it's some kind of hybrid infrastructure where the external network connectivity is expensive. You don't necessarily want to run an extension that goes and deploys from somewhere on the cloud. Maybe you want to install from some kind of share, or you actually want the whole installation script contained in the VM scale set properties. Well, you can do that. You can use what's known as custom data, which is a property in the virtual machine profile for a scale set. And here you can basically encapsulate everything that needs to install directly in the definition of the scale set. So we find a lot of hybrid deployments use this. And similarly, there's a property called unattend in Windows virtual machines. And you can use unattend as well. Some people may be familiar with that just if you've worked with Windows a lot. So unattend will effectively log in, run anything you need. So I've seen a lot of kind of hybrid banking, financial analysis type applications that will use unattend to go and do the deployment, of a virtual network file share in the same virtual network, so it doesn't have to go out and get any data. Another way, now suppose you're deploying an application that requires .NET 4.6.1, and as part of deploying that, it requires a reboot of the VM. That's a little bit inconvenient if you're trying to run that from an extension. What's the extension going to do? It could get a little bit complicated. And that's where using some kind of configuration management can come in very handy. So Azure Automation DSC is a good example. There's an example template in GitHub that uses DSC. If you let a configuration manager, like Chef or Puppet as well, if you let a configuration manager and manage the application, typically you run some agent that you install through an extension on all of your VMs, and the agent then connects maybe to a virtual machine in an availability set or some kind of configuration manager on the cloud and manages the state of that application. That's very useful in terms of central management. So it can be very, as soon as you get a little bit complex in installation, or you just want to make sure all of the VMs are on the same version, then using a configuration manager can be a very good idea. I think I'm about 5 out of 6 different ways to deploy applications. Containers. A lot of people increasingly are using containers like Docker containers to deploy their application. Why would they do that? Well, maybe I'm creating an application that I also want to install on premises, or maybe I want to install it on Amazon Web Services. Why don't I just have that application contained in a Docker container, or I kind of have some kind of microservices architecture where I've got multiple Docker containers. I want to be completely independent of the infrastructure. So I want to lay out my scale set, and these are just stable. It's a stable infrastructure for the containers. It doesn't need to be patched too often. It's because it's independent from the application. So I think we'll be seeing this model much more. A container orchestrator then manages the application lifecycle management. And I think we'll also be seeing combinations of these, including containerized, particularly with Windows containers coming up as well. So then containers becomes even more of a universal architecture concept. And lastly, I'll talk about a custom image. So pretty much all the options that I mentioned before, when you're deploying a VM, something runs at install time. There's some kind of installation taking place. Suppose you don't want to run anything when the VM is created. You just want the VM to be deployed as fast as possible, particularly if maybe you're auto-scaling. You want the complete solution there in a virtual machine. So again, a lot of people use a custom image. If you're going to use a custom image, though, how do you update your application? If you change some code, what's the process to build a new virtual machine and deploy it? That can get a little bit time-consuming to maintain that. So typically, you will need some kind of deployment pipeline to do your build, to do your test, to do staging, to put it in production. If you think of the example of Netflix, for example, they built an open source product around this called Spinnaker, where it follows the immutable model, where you build everything into a virtual machine image. Once you've updated your application, you throw away the old virtual machine image, and then you just move this chunk into your infrastructure. That's the immutable model, and Spinnaker has been ported to Azure as well. So you can actually use this pipeline model. It includes basically your pipelining for testing, staging, production. I think it also incorporates Packer as well. You can incorporate that into something like Jenkins to basically build out a full CI/CD process. And once you have that in place, then it really can be as simple as a developer checks in code, an automated process then builds a virtual machine image, it goes through all this testing and staging, maybe there's a manual process to make a go, no-go, and actually goes and deploys that virtual machine into a scale set. So if you need to use a custom image, then you probably have to get into the concept of deployment pipelines, but once you do, it can be a very efficient way to go and deploy your application. Also, Azure Dev Test Labs are working on this concept. So this is kind of a bit of a preview, but basically, Azure Dev Test Labs are exploring the concept of having this, what they call an image bakery, where they can help you build, and then Visual Studio Team Services has a testing and staging production, pipeline as well. If you're interested in that, come and chat at the end. I think I can give you some better links. I just saw an email just before I came up here for a new link for the latest on using the Azure Dev Test Labs. So I think, again, this is one of those things that you're going to see more of, just like containers. I think there's going to be more infrastructure built around an immutable deployment pipeline. Since I went through like 6 different methods, I thought I'd include a handy cutout and keep guide to when you would typically want to use which application deployment method when you're deploying a scale set. And like I say, a lot of applications will use more than one of these methods. So really, this is just a summary of the basic methods and why you would use them. I was thinking of making it a test, but no, I'll just include this simple reference. But let's look at a real example now. I've been a bit too theoretical. So let's look at the concept of, this is an open source project, which is actually widely used in hospitals around the country. And the problem they're trying to solve is high-performance MRI image reconstruction. Now, if you imagine, say, a child goes to a hospital with breathing problems, and you want to do an MRI, you can't ask them to hold their breath for a minute while the MRI is clunking away and bringing back data. You really need to get like 3D image in real time. And the hardware is capable of churning out that amount of data, but it's very compute intensive. Typically, you would need well over 100 modern cores running, crunching that to be able to bring that data back in real time. So there is a solution, it's called Gadgetron, and it's been, an Azure module has been written to it where you don't have to invest in that hardware, you can just burst to the cloud. So when a new imaging job comes in from a hospital, a VM scale set gets created, initially with a capacity of 8 F16 VMs. So these F16 VMs are very compute intensive. They've each got 16 cores and 32 GB of memory each, 256 GB of SSD, and 8 VMs running in a scale set can then do all the processing to send back the 3D imagery in real time. So they can watch the patient breathing, their heart beating, and actually use that data. And then if multiple jobs come in from the same hospital, they can just increase the capacity. They can just scale out this scale set. And it can go up to, at the moment, I think the source code, it goes up to 32 VMs. And it typically adds another 8 nodes in about 3 minutes. So once you signal you want to start a new job, it's pretty quick that all the resources are ready. And as you can see, it's using three of those application deployment methods that I mentioned. It's using custom VM images just so that the whole application can come up as quickly as possible. And then there's a custom script extension which runs just to customize for that particular job once it comes up. And then there's also the built into the custom image is a Docker container, because that way they can use the same solution if the hospital has their own hardware or their own data center, or if they're using another cloud provider, that same Docker container can be built in to that infrastructure. So it's a really portable solution. It's used quite widely. There's also, to save cost, there's an automatic shutdown timer. So once it's not used for more than a few minutes, basically once the job finishes, you don't have to remember to go and delete those resources. You can save money. So it's a really, in a sense, it's an archetypal cloud value prop application that works really well. There's a very clever guy called Michael Hansen that wrote a lot of this, and you can see his templates there. And also we have Jason Ingram here today, who is a Microsoft Cloud Solution Architect who built a lot of the Azure components. So if you want to chat about this more later, then yeah, we can talk some more about this solution. So that's the basics of creating a scale set and deploying. What about monitoring? Well, if you've not looked at scale sets in the portal for the last week or so, you may have missed some of the new things that have been built into monitoring. So perhaps I'll just take a quick look at my portal. So if I go to my dashboard, and then I'm going to go to, let's see, which one shall I pick? I think I'll pick, I have a scale set called Big Core, and if I click on the resource group, and then I'll click on the VM scale set. So you may notice a few things that look a bit new. For one thing, there's now a graph that shows resource usage. Now, let's scroll down a bit, or I'll make this a bit bigger. It says I'm using 0% CPU, but I went up to 0.09%, so I think I probably need to add some more VMs soon. But if I click on this graph, I can edit various properties. Let's see. So I can edit the charts, I can add various other metrics, and these metrics are going directly through the host, and Neil is going to talk a little bit more about why that's a good thing, and some of the new developments in terms of reporting resource usage. If you notice, the portal is maybe having a little bit of trouble with the network, but down below you can also drill into individual virtual machines as well and see their status. And as well as other things, like you can actually do management operations on these VMs as well. So there's a lot more. All of this has come in the last week. I think it was a bit of a problem we had when we first launched this service in terms of how well integrated scale sets were in the portal. Well, this is changing a lot. So if you haven't looked recently, you can go look at this. And if I go click on this graph, then one of the other things that have been added is you can configure alerts as well. Let's see if I can. In fact, rather than, oh yeah, so here you are. So you can, there's various options. You can edit this chart, and then there's an option to add an alert as well. This can be really useful, because if you really want to monitor your application in real time, maybe you want to perhaps get an email address when CPU usage averages 80%. You can set all this up with this alert as well. So that can be very useful. And if I switch back to this, I'll just go through these. I basically captured screenshots of these. And then the other thing that you can do, as well as add alerts, is you can explore the audit logs. So there's fairly sophisticated insights into the audit logs of events, like a new scale set was created. There was a scaling event. So you can go and do sophisticated queries into these audit logs as well. So there's quite a lot that has been added into the portal. It's not, if you look in the portal and you don't see it, you may be one of the 5% that this hasn't rolled out to yet, because these are new features that are rolling out across the world, and they should be in every copy of the portal within the next few weeks, but I think most of you will see these now. So one more thing I'm going to talk about then is you've installed your scale set, you've got your application running. How do you manage upgrades and patches? This is one of those things we get a lot of questions about, so I think it's worth understanding how it works. There's three basic types of application updates. One of them you could think of just application. So if you use, say, a configuration manager or a container orchestrator to deploy your application, then you don't care about the underlying infrastructure to manage your application lifecycle. So that's one of the advantages of using that method. So I don't need to go into detail about that. However, if you're using, say, extensions or if you've deployed in one of the other methods, you probably need to do something with the VM itself. So I'll break that into two methods. One is in-guest updates. For example, I log onto the VM and I run Windows Update to get the latest updates. For a VM scale set, obviously you don't want to do that because when you scale out and you create a new VM, it's just getting it from the source image and it's not updated. You'd have to remember to go in and update that one. So the way you'd probably do that is create an extension to actually run those updates. So anytime a new VM is created, it will run the extension and apply any updates. Even then, eventually, you'll probably want to replace the VM image anyway. Perhaps you want to upgrade your operating system version altogether. So then there's VM image updates. And they have something in common with using an extension in that you can update, when you update them, there's the concept of the VM scale set model, which is how it's defined. And then there's a concept of applying that model to individual VMs. And that way you can roll out an update. So it's really two steps. You update the image reference in the model, and then you upgrade the VMs. So if you look at the model, i.e. that template that I flashed through really quickly, it has several properties which you can update, and then you can go and redeploy that template, and then it has a new model which is now out of date from the VMs. Unless you set an upgrade policy to automatic, in which case it will reboot all the VMs and they'll all be updated, which generally you probably wouldn't want to do, although in some cases it's useful. So if I change one of these properties, then I can call manual upgrade on these VMs, and away they go. It looks like I must have changed VM size. There's one other property, which is capacity, which is different in that if you change capacity, it doesn't affect individual VMs. It goes and creates new VMs, or it may delete existing VMs. So why don't I do a quick demo of then how I can use this. Now in the portal, I can actually apply a manual upgrade to, I can click on a set of VMs and apply an upgrade to it. But if I want something a bit more automated, then I could just call the update API directly. So I'm going to go to, I'm going to run VS Code, his little Python program, which just creates a tool that I can use to update. So I'm going to run this tool. And then it brings up a window here where I will go and pick probably the same one I looked at, same VM scale set I looked at in the portal, and show the details. So here, I've got my scale set broken down into different fault domains. Let's suppose I want to change the OS version. I'm going to change it to, it's Core OS 899.15. So I'm going to change it to 1.7. And I update the model. So all it's done there is that definition of the scale set. It's updated and redeployed it. And because the upgrade policy is set to manual, it doesn't actually do anything else. So it said that the response came back as a 200. That means it successfully requested the update. And then in a few seconds, it should come back as success, meaning the update took place. So I'll just wait a couple of seconds, and there it says succeeded. So what I can do next is I can maybe pick a batch size. I'm going to say I want to upgrade one FD at a time. So I'm going to say this is a scale set of 50 VMs, so I'm going to say update 10 VMs, and I'll click on rolling update. So all this code is doing, it's picking the first 10 VMs that it finds in FD0, and it's issuing a manual upgrade call on them, just like you could do with the portal. Except What's nice about just programmatically or scripting it is that I can choose how long to wait in between. I could run my own tests. I could say start with one VM, check the upgrade works, and then maybe do 5 VMs, and I can really customize it. And that way, I can roll out an update. And I could update any properties, not just the OS version. I could maybe change the size. Wait for this train to go past. So I could update the size and roll that out as well. And off it goes. It's rebooting them. And it's going to roll out. We can check on that later if I remember. It'll roll out across the scale set, and it's done. So it's a nice, simple method of being able to update any of these properties, but not losing service availability. This is all open source, by the way. You can go run this yourself and play around with it. Next, I'm going to talk about scale, which is really, like I said, it's a key value prop of VM scale sets. It needs to be easy to change the number of VMs in a scale set. Let's distinguish horizontal scale versus vertical scale. So vertical scale is changing the size of my VM scale set. And I could change the size in the model and then roll it out just like I did for the new OS version. Horizontal scaling is what people typically do, is just change that capacity value. And again, when it creates new VMs, it spreads them evenly across fault domains. When it deletes VMs, it deletes the last ones created first. So again, they remain evenly spread across fault and update domains. So you change the number, and then you redeploy. The VM ID always increases. So you're never faced with the same VM having the same ID. It will always go up. Eventually, after millions, it will get reused for ones which aren't, for VM IDs which aren't being used. So it always deletes by the highest ID first. Similarly, you can very easily scale with PowerShell and CLI. So with PowerShell, there's a get Azure RM VMSS call, which basically gets the model. Then you can change the model, the capacity in the model, and then you can do an update, which basically sets the new capacity. Now, with PowerShell, we'll work on a scale call so that it's just easier like it is with CLI. With CLI, it's Azure VMSS scale. You give it the resource group name, the VM scale set name, and the new capacity. That's how easy it should be. In fact, we'll probably work on the API, so it's just one simple call like that. You can do this with any tool which edits the VM scale set model. So a good example is Resource Explorer. If you haven't seen the Resource Explorer, resources.azure.com, it's a really good way to understand your Azure infrastructure. And you can go and edit it and then do a put, and you can just go change it directly in there. And that will also be integrated into the portal very soon, so you can just change the capacity. It's one of those things that it probably should be one of the first things that we do, and so it's definitely next on the list. So that's all about scale. What about Autoscale, which I think was in the title of this session? So for Autoscale, I'm going to scale out to Neil.
All right.
That wasn't very funny, was it? Okay.
I appreciated it.
Okay.
Can everyone hear me? Even in the back? Solid. All right. Let me just log into my machine. Awesome. So, Autoscale. Why should you care about Autoscale, right? Why is it not just good enough to say, hey, I've deployed my infrastructure, and it's good, it's working, I just want to leave it? There are a variety of reasons, but today I want to highlight 3 in particular. Let's imagine that you are an e-commerce website, or rather that you have an e-commerce website, and you have your payment management system for that website. Let's say you've deployed 3 nodes for it, right? Your website is going along, doing fine, you're accepting payments, and then all of a sudden, you get twice as much traffic as usual. And if you're still on 3 nodes, maybe that's enough to keep processing these transactions, but maybe not. Maybe you start throwing errors because your nodes are overloaded, and you're literally turning away people who are trying to give you money, which is never a good situation to be in. So that's the first reason you might care about Autoscale, is app resiliency. The second reason is reduced cost. After that spike in usage, you don't need those nodes around anymore, necessarily. Maybe going back down to 3 nodes is good enough. And you don't want to just keep those extra VMs lying around, because those will be cutting into your bottom line. So reason number 2 is reduced cost by scaling back in. Always remember to put a scale in rule when you have a scale out rule. Otherwise, you'll just keep growing and growing and growing, and that's not always a good situation. And then the third reason is notifications. When you have a system that can automatically scale in and out, you generally want to know what's going on with your system. You don't want to think you're on 3 nodes when you're actually on 20, right? And this is particularly useful because you don't always know whether load that's on your site is good or bad. It might be that you have a lot of new users that are trying to buy things off your e-commerce site, but it could also be that someone's trying to denial of service attack you. And you at least want to know when you're under increased load so that you know, hey, I really don't think I should have this much load. I should probably investigate why this is happening. OK. So hopefully I've convinced you that you want Autoscale. And so let's talk a little bit about how you get it. So let's go back to the portal real quick. Wrong machine. All right. So I'm just in the Azure portal. I'm going to say new. Type in scale. And the first hit is virtual machine scale set. Create. I'm going to say scale VMSS. It can be a Windows or a Linux VM. Type in my username, password. No, mistyped it. I see. It doesn't like copy and paste. Yay, got it. And it's going to create in US West, and that's fine. I'm going to provide a domain name label. No, OK. My fingers are not working too well right now, but that is OK because I have this nice screenshot back here. So if my fingers are working a little bit better, you would see this nice little configuration section, which allows you to enable or disable your autoscale directly in the create experience. It allows you to specify the minimum number of VMs and the maximum number of VMs, because again, you don't want to unintentionally spin up to 1,000 nodes just because someone's trying to attack you. And it allows you to specify a threshold for when to scale out, when to scale in, and by how much you want to scale out and how much you want to scale in. So once you've deployed this, and thankfully this next part doesn't require me to type anything, what if you made a mistake? What if you decided, oh man, I set it to 75, but really I want to scale at 50%, or something like this? You can go to the Resource Explorer, resources.azure.com that Guy was talking about earlier. And this shows you in JSON essentially all of your infrastructure that you have. And you can come here and click the Edit button. And once you're done making any edits, as Guy was saying, you can just hit this Put button, and it will go and update things for you. In this case, we can see that this scale set has a min of 1, max of 10, and a default of 1. Quick show of hands. Who here knows what default means for autoscale? Sweet. Default is the number of VMs that your scale set will be set to if, for some reason, Azure is having trouble reading metrics. So if, for some reason, we cannot read the metrics and say, oh, hey, you're at 80% CPU, or you're at 20% CPU, default is the amount we will scale to. So that's just a useful tool for making sure you always have enough, even if we can't quite tell what's going on with your resources. And we can see here that we are scaling on processor time. We are averaging over 5 minutes. And if that average is greater than 60%, we are going to increase the number of VMs by 1. And we have a similar rule here that is saying if the average is less than 30%, then decrease by 1. So you could come here, edit whatever configurations you want. and just hit put. And it's a nice sort of GUI way to edit your configurations if you don't necessarily want to pop into the CLI. This just makes it easy for you. OK, now one thing to note about Autoscale today is that you have to install an agent in each of your VMs called the Windows Azure Diagnostics Agent for Windows, or the Linux Azure Diagnostics Agent for Linux. That is today. And we will be talking a little bit later about some exciting improvements. So get excited. Let's talk a little bit about what this looks like. As you can see, at the top, we have the VMs in the scale set, each, in this case, with the WAD, Windows Diagnostics extension installed. These metrics get pushed out into Azure by these extensions. They get aggregated and stored on the right in that area called Insights Storage. That is a customer storage account. So if you want to use Autoscale, you have to create a storage account for it to store the metrics in. And then there is this Autoscale service background job that runs every 5 minutes today that will read from that storage account, look at the rules you specified, and decide, based on that data in the storage account, do I need to scale out or scale in? And if it decides yes, it issues a call back to the scale set to change the capacity. And it logs that entry, which we can see in various places, including the portal. That background job is running on the Azure backend. The customer doesn't need to know about it or ever see it. Yeah, it's not on the VMs. It is, yeah, the question was, is the frequency at which Autoscale runs configurable? I believe it is, correct? Yeah. But today, the minimum is 5 minutes today. I'm just going to keep reiterating that because I'm super excited. All right. So far, we've only really talked about basic scenarios like, oh, if you want to scale on CPU or network usage or something like this. But a lot of times, you might have a scenario that's a bit more complex. You might have weekly usage patterns, right? So going back to the example of an e-commerce website, maybe you have the most traffic on Saturday, right? But you don't necessarily have a lot of traffic on Monday because people just aren't shopping. It might also be that you have a sale coming up, and you want to make sure that you have enough VMs to handle your load ahead of time without waiting for your VMs to become resource constrained. And you can do all of this simultaneously with Autoscale. All of this is defined in that JSON block for the Autoscale rules in the Microsoft.insights section. And there are these 3 types of scaling. Scaling on a specific day, scaling on a recurring schedule, and scaling on resources. So what happens if these conflict is a question we often get, right? You might have a rule that says, OK, on Saturday morning, scale out, because I know I'm going to have a lot of people trying to buy things. And then Saturday evening, scale back in because my load is dying down. People aren't buying things anymore. But what if you have a one-time sale this coming Saturday, right? And so you put an additional rule that says, hey, this Saturday only, scale out for me. Well, now we have one rule saying scale in, one rule saying scale out. What do we do? To solve this problem, Autoscale defines an order, a precedence. And that precedence says specific day scaling has precedence over recurring schedule scaling, which has preference over resource metric-based scaling. So in this scenario, because the specific day scaling rule says scale out, your VMs will be scaled out, so you can handle that load. And as I said, this can be a bit complex at times, and we will be adding a lot of functionality into the portal to make this easier. But there's also already several things in the portal that can help you debug this. So Guy already showed you the activity logs, or the audit logs. These are a great place to go to check, hey, I think there's a lot of load being applied to my scale set. I think it should have scaled out. Am I actually seeing it scale out? Without having to constantly look at your resources and see what they're doing. So as Guy showed before, there's these activity logs where you can see this. And the events for scaling, there's one highlighted over there. You can see a scale down event. That's actually a bit of a misnomer. It's really a scale in event. It's changing the number of VMs, not changing the VM size. So one of the big three things I talked about in the beginning was notifications. So what kind of notifications can Azure give you on your autoscaling? So the first one, as Guy mentioned, you can have automated emails triggered. So when there's an issue or something that's looking odd, you can email your ops team or what have you. I hear that they love it when you do that. But you can also integrate with external APIs via event hooks. Now, these event hooks come with a basic payload that says what resource is triggering the alert and this sort of information, basic information. But you can also add your own custom information to it to satisfy whatever third-party dependency you have. And the screenshot on the bottom is a screenshot from PagerDuty, or rather, it is a screenshot from the JSON configuration that I showed earlier that integrates with PagerDuty. And so in the part where it says operations scale, that is saying that on a scale event, we want to make a call out to that URI, which is events.pagerduty.com/integration/ a unique ID given to me by PagerDuty, which I don't want you to necessarily just start hitting right now, so I removed it from the slide, /enqueue. And when a scale event happens, we will make a request out to this HTTP location, and that will cause PagerDuty to then trigger an alert to me. And actually, let's take a quick look at the PagerDuty configuration. All right, so it's a very simple configuration. As you can see on the top, this is just a free trial that I'm using. Immediately after an incident is triggered, notify me. And in the me section, you can configure your cell phone and have it give you a text or have it give you a call, and of course, email as well. And this is a very simple configuration. You can also do more complex things, such as associate this with a specific team, or if I'm not responding, if I'm asleep and I don't wake up, then escalate this after a certain amount of time to, say, my manager or someone else. So this integration with third-party tools allows you to have this sort of rich experience that may not necessarily be built into Azure, but is built into these other third-party platforms. So one of the things that's awesome about how we implemented this is that it's actually very simple. We've made it very open and easy for you to build your own autoscale layer. Because we expose all the metrics for your resources through a REST API, it's very easy for you to grab those metrics and make autoscaling decisions however you want, even if it's something we don't support. So why might you want to make your own autoscale layer? Well, that might go back to Guy's example earlier of the hospitals using scale sets to do the image construction. Oh, excuse me, my phone has gone off. That's actually PagerDuty telling me that something's going awry on one of my scale sets. Just before starting this, I just applied a little bit of load. So there you go, notifications. But yes, you might want to build your own autoscale layer because in that case of the MRI, they don't necessarily want to look at CPU utilization or whatnot. They know they have a new stream of images they want to do analysis on, and so they have a custom autoscale layer on their metric of how many streams of images they're pushing to us, right? So they don't need to be constrained by our choices, what metrics we offer. They can take their own data And it's very, very easy, just a single HTTP request to make that change in capacity. So it makes it very simple to write your own autoscale layer if you want to. I've been talking a lot about first-party tooling, and I showed you the PagerDuty example. There's one other third-party integration I want to highlight here, which is Datadog. Datadog shows metrics and alerts for both Azure VMs and scale sets. And this screenshot on the right is actually a Slack notification generated by Datadog on a scale set that is telling me that the CPU usage on my scale set is below the normal amount, so it's probably something I need to investigate. And if you see in the bottom of the notification is actually a graph. That graph is the last 5 minutes of CPU utilization for my scale set. And so because we've sort of kept this open and we have these third-party integrations, you can get this nice experience where even before you've left Slack, which might be your chosen, preferred way of communicating, you can already see, get a sense of what is going on with your scale set before you even start to dig deeper. So what's new? I've been sort of hinting that today Autoscale works like this. Well, tomorrow Autoscale looks a little bit more like this. There's a big X on the WAD extensions. They still exist if you want to use them. And there's also a big X on the customer-owned storage account. That is because we are rolling out host metrics. I think Guy mentioned before, we now have the ability to gather metrics on your resources directly from the host. You no longer need that in-VM agent shipping out that data, which is awesome. You also no longer need a storage account. All of that data gets shipped into an Azure-managed data store, so you don't need to worry about it. You don't need to be managing that. So you can tell I'm excited about this. Why should you be excited about it? First is that you don't need to configure any of those extensions anymore. It all just works. These metrics come at a smaller time granularity, 1 minute. So someone in the audience around here asked if it's configurable, and we said yes. You can configure the time granularity. And now metrics are going down to 1 minute. Autoscale is still at 5 minutes, but it will be going down to one minute in the future. So look for that. That's super exciting. And it's also more reliable because weird stuff can happen in the guest, right? The guest might be running at 100%, in which case an agent in the VM might not have the cycles to be able to report metrics out properly. And so for other reasons like that, gathering the metrics from the host is more reliable. So look for this. This is rolling out soon. Should be very exciting. One other thing I would like to cover is attached data drives. This is critical for workloads like big data workloads, Hadoop, for instance, stateful workloads that write a lot of data to disk and need to store terabytes on a single VM, and also lift and shift scenarios where you might have an on-premise application that expects to find a data disk on the VM, and now that we will be supporting this, you no longer need to rewrite your app to no longer look for this data disk and do something else. It should be very easy to just plop that app onto a scale set in any of the 6 ways that Guy highlighted, and they should just work. So we give you the capability to attach data drives to your VM scale set. But along with that, in the same work, we've made some other improvements as well, such as custom images supported at scale. Today, when you create a scale set based on a custom image, one that you build and bring to Azure, as opposed to one that we have in the gallery, it is limited to 40 VMs. As this is rolling out, this will no longer be the case. We will now be able to support them, custom images, at scale. There's also no more need to pre-create storage accounts for these disks. It all just work behind the scenes. And so how will you specify one of these data disks? In your JSON for your scale set, you will be able to specify the data disk's key. And the value of that key is a JSON list, where each entry in the list represents a data disk. So in this example, we are creating an empty data disk. You could also attach from an existing blob or the like if you want. And the disk size is 100 gigabytes. And as an example of why this might be useful, I have here I'm not sure how many of you are familiar with Elasticsearch, but this is an Elasticsearch cluster running with Kibana as the front end. And we have it preloaded with the complete works of Shakespeare. So this is running on a VM scale set with a attached data drive. So it enables you to store a lot more data than you otherwise would on just the OS disk. So here, let's do a fun little query. Let's find all of the Shakespeare lines spoken by Horatio. Boom. So there are a lot of workloads or a lot of companies that like to use the Elasticsearch workload and other big data workloads as well. And these are the sorts of workloads that we are hoping to unlock with attached data drives. And for the rest of the roadmap, I'll hand it back off to Guy.
Thanks, Neil. And one more thing about attached data drives. If you want to play with them, or if you have a workload that requires attached data drives, come and talk to us. At the moment, it's in limited preview. So all the things we're really demoing and showing, you can actually use them. It is available to use. So you can have your account whitelisted, and you can try them in preview, because they are coming soon. And a few other things that are on the roadmap. As we mentioned, the portal work is just ongoing. There's a lot more coming in the portal, so watch the next few weeks. As I mentioned, just being able to do things like set scale, better Autoscale integration. And then another thing people ask for is larger scale sets. So some of these big workloads, you can have an application that uses multiple scale sets. If you look at Azure Batch, for example, they have a scaling unit of a 40 VM scale set, and then they just build them up to thousands of cores. But there's a lot of scenarios. Let's take the Hadoop scenario again, where you just want a lot of scale sets a lot of VMs in just one scale set. So we've been working on larger scale sets, and to show that we're not just saying we're working on it, to show we actually are doing something about it, let's do a quick demo. And I'll show you a scale set that has not been seen outside of the engineering team until today. So let's go to, I'll minimize this to make it a bit more visible. Let's go back to this tool that we used to show a rolling upgrade. And as you can see, the rolling upgrade, it went through all 5 FDs and it succeeded. But I have another scale set, which I have imaginatively called Big Test. And I'm going to click Show Details. Now this scale set, it says they're all powered off, but here you see 300 virtual machines. So what we've done is we've basically expanded the size of the cluster and the number of VMs that you can fit on this. And this is running in production. So if you have a need for larger scale sets, again, come and talk to us. We can talk about a preview for this technology. We're not done, though, at like 300 VMs. I just started them, so you can see them all coming up now. I had to write a bigger version of this tool to fit them, which felt good. But we're not done here. We're pushing this much further this year. So we're doing a lot of work there. So just let us know and come and talk to us about that if you think that this technology might be useful for you. What else are we doing in the portal? That rolling upgrade demo, it's all very well. That's a kind of a client-side demo. But then some people still miss what you could do with PaaS v1 with worker roles, where the OS could just upgrade and you never had to think about it. It was fully automated. A lot of people have asked for that with scale sets, so we've started heading in that direction. And the first step to that is to incorporate some kind of rolling upgrade technology into the definition of your scale set. So you can say, when the model changes, push a rolling upgrade and use a batch size of this, use a pause time between batches of this long, and run this script to verify that it was successful. So we're basically going to have configurable automated rolling upgrades as a first step. Ultimately, we'd like it to be, for people who just don't want to know about the OS upgrade, they just want it to happen, we'll keep working in that direction for scale sets as well. There's other things people had asked for, certain network enhancements, like I want a public IP on every VM. Some of the things like that we're also working on. PaaS and application runtime features as well. I want to be able to get things like, we're providing a service runtime library. I want to be able to do more to check application health. I want to do application draining before I scale down. There's a few things like that we're working on that will make scale sets kind of more equivalent in functionality to PaaS v1 worker roles, but at the same time providing all the customizability that you expect with an infrastructure service. So that's the things that are keeping us busy this year. So you can see expect a few more announcements along these lines as the year goes on. In terms of next steps, we've included a few reference points that document some of the things that we went through. Some of the things like I want to create a scale set using PowerShell, or how to create using CLI, what are the best practices for Autoscale, some of the more advanced Autoscale features that Neil went through. There's some of this is documented, which could be quite useful. You're welcome to reach out to us as well if you some of this we went through too quickly or it didn't make any sense. Just reach out to us. I think I've got a few business cards. I can give you a Twitter handle or however you like to contact people. There's also the link to that scale set editor that we used for a couple of the demos. It's all open source in GitHub. So it's just a simple Python program that you can explore and extend. There's a few other sessions that cover similar topics or some of the services that built on top of scale sets, things like the container service, etc. So I just included this for reference. And we've saved a few minutes for questions. So does anyone have any questions on anything that they've seen today? Yes. Is there a microphone, by the way, for questions? Oh, yeah. You don't have to use it, but
okay. As long as everybody can hear me.
I'll repeat it anyway.
You said that we will no longer have to have a storage location provided by us, that as it can be taken. Now, are we going to be able to have access for that storage going through Power BI or analytics on our own? And is that storage location like Azure Table or cloud storage that implements some kind of security?
Okay, so the question is, this new storage that we don't have to pay for ourselves, is it going to be, how's it implemented? Will we have the same access to it? I think Neil can probably show an example of how to query it, but basically you can query it as a REST API, and I'm not sure, do you know anything about whether it's encrypted or any details like that, Neil?
That much I'm not sure.
Okay, so we can actually, if you want to give me your contact details, we can get back with more information about that. There's also another session on at the same time, which you just missed, which is all about the new Azure Monitor service, which goes into more detail about that. So you could catch up with the replay of that as well.
So does this tie into that monitor service?
Yes, it does. So it's fully connected with the monitoring service. Any other questions? Yes. So the question is, what about log analytics, OMS, etc.? We're actually working with the OMS team. Log analytics, you can make use of these audit logs. So a lot of VM scale set events are in the audit logs. We're working with the OMS team to actually have much more there. So there'll be a few things in the roadmap for better integration with OMS and also the security center. So when you're scaling in to not use instance ID, but to use what?
To have any type of on-stop event.
Oh, an on-stop event, yeah. So it really comes back to application draining. And yeah, we're definitely working on that. So that, again, that's coming soon. But it's on the way. Any other questions? Feel free to just come up here and chat some more. But with that, I'll say thanks a lot for coming and listening to this. Appreciate it.